Alright, hi Calc class. It is Saturday morning about 10:30. I have my three little hoodlums with me this morning, so I'm sorry if we are a bit distracted. Grace and Sophia and Elijah is back there too, are going to be playing while we are doing our calculus. So girls, say hi and then go find something to do, okay?
Hi. Hi.
Alright. So, skip and review, going right to what we're going to do today. We're talking about the mean value theorem and what that means according to like speeds and those sort of things. And then talking about increasing and decreasing functions. I think we'll hopefully be able to get all that done within 15 minutes or so. Here is our mean value theorem. It says this: if y equals f of x is continuous at every point on a closed interval and differentiable at every point of its interior from A to B, then there is at least one point C in A to B at which f prime at C equals f of B minus f of A all over B minus A. What is that talking about? Well, that is talking about this, that at some point the actual slope of my graph is going to be equal to the average slope taking my two endpoints. If you look at the graph, it kind of clears things up a little bit. Here's my graph, here's an A, and here's a B. I drew a line between those two and found the slope. That's called the slope of the chord. That's f of B minus f of A all over B minus A. That's this part of my mean value theorem. The other part is saying that at somewhere on your graph, you're going to have a derivative, a slope, that's going to equal that slope of the chord. And so in this particular example, it happens right here, where that slope is the same as that slope. So where the slope of the tangent at some point C equals the slope of the chord using your endpoints. That's our mean value theorem. It makes sense if you think about it in a couple different contexts. If this graph was just a straight line, then that slope would be the same everywhere. So that C value would happen at lots of different places. If it goes up first, a steeper slope, it's going to have to come down a less steep slope. So at some point, it's going to have to be equal to that. The same thing would happen if you go down first and then up. Come here, buddy. Elijah just hit his head. We'll be okay. It's going to have to equal out to be that number in between. Anyway, a couple special notes I put on mine that are not on yours. I don't think you need to write them down, but just maybe make a special mental note. Did you hit your head?
No.
Yeah, need a kiss? There you go. Want to go play?
Yeah.
Okay. That, since it says it's differentiable, that implies that it's continuous. So you don't necessarily have to say that it's differentiable and continuous, although it is continuous on the closed interval and differentiable on the inside, so not on the closed. But the mean value theorem will only apply if it's a closed interval. So if you say it's a closed interval and it's differentiable, then it's meeting all the requirements of the mean value theorem. Another thing that I mentioned, but I'll point to and make special note of, the mean value theorem says that at some point in the closed interval, the actual slope equals the average slope. So what that is telling us is that at some point it's going to be there. The mean value theorem is an existence theorem. It's not a theorem that tells you this is where it is or this is how you find it. It's saying that it does exist, that there is one. Then it's your job to figure out how to get that. Let's look at this specific example. Show that the function f of x equals x squared satisfies the hypothesis of the mean value theorem on the interval from 0 to 2. Then find a solution C to the equation f prime at C equals f of B minus f of A over B minus A on this interval. Alright, so first saying that it meets the requirements of the mean value theorem. Since it is continuous from 0 to 2, and it's differentiable from 0 to 2, it meets the requirements of the mean value theorem. End of story. Now we actually have to figure out how to get that point. So I'd probably start by doing this part of it. So I would take f of 2 minus f of 0 all over 2 minus 0. Putting that into our function, 2 squared is 4, 0 squared is 0, over 2 minus 0, that'd be 4 over 2, which is 2. So the average slope, the average rate of change of this function is 2. I want to find a point point from 0 to 2 where that derivative actually equals that. So now I take my function's derivative of x squared is 2x, and I set it equal to 2. Divide by 2, x equals 1. So the c value, the where does it happen, is at x equals 1. The what is the actual average, is 2. So we just use the mean value theorem to show that the average slope is going to be equal to the slope at some tangent in your graph. What's the matter?
Ball.
What about the ball?
Leo.
Okay, go get it.
Leo.
I can't help right now. Go see if Grace can help you.
Leo.
You have the graph on your paper kind of showing you what that's actually looking like. This average slope is the same as the slope of that tangent. Okay, so kind of shifting gears a little bit, talking about increasing and decreasing. This is something that we've alluded to, never put down in an actual problem, I don't believe. It says that f is increasing. Wait, did I skip one? Yeah, this is the one I meant. If my derivative is positive on my interval, then f is increasing on that interval. Notice we do say it's a closed interval that it's increasing. Some calculus books will say it's an open interval, and some say it's a closed interval. So since it's like contradicting in different books, the AP exam won't be super hard on you whether you put closed interval or open interval. We will say increasing, decreasing is a closed interval though. So I'm going to stick with what our book does and say it's closed interval. If my derivative is negative, then it's decreasing on that interval. And that makes sense to us. Positive slope means it's going to be going up. Negative slope means it's going to be going down. Alright, so here's an example of that. Where is the function f at x equal 2x cubed minus 12x increasing? Well, if I'm going to figure out where it's increasing, I want to know where is my derivative greater than 0 and where is my derivative less than 0. And to be able to figure that out, it might also be beneficial for me to start with finding where it equals 0. So my very first thing I need to do if I'm doing this analytically is find my derivative. So your derivative, 2 times 3 is 6, x squared minus 12, and I'm going to start by setting it equal to 0. So we add 12, divide by 6, and take the square root. Remember, we have two solutions. X equals plus or minus the square root of 2. So this is what I know, that this is my derivative, so my maximums and minimums are going to have to happen on those points. So I have just a quick sketch at negative square root of 2 and positive square root of 2, I have zeros. So I'm trying to figure out whether my graph is above or below on these different intervals to figure out where it's increasing and where it's decreasing. So let's start by finding increasing, where my f prime at x is greater than 0. So when is 6x squared minus 12 greater than 0? X squared is greater than 2. This is why I had you find those zeros first, because I think this is kind of hard sometimes to think about how that would separate out. If I need the square of my number to be bigger than 2, then that is going to have to be numbers out here and numbers out here. As you split up this, you get the absolute value of x is greater than 2. But you have to split your absolute value, and when it's greater than, it splits up into, oops, I forgot my square root symbol. It splits up into bigger than the positive and less than the negative. And if this part is super confusing to you, then I want you to just think of it what it would be on the graph. So it's going to have to be farther this way to square it and be bigger than 2, or farther this way for you to square it and to be bigger than 2. So then I can answer the question, where is it increasing? It is increasing to negative square root of 2. And remember, we said increasing, decreasing, we typically do closed intervals. And then it's also going to be increasing from square root of 2 to infinity. If it's increasing there, we check the decreasing, so we split this. And now we're saying, where is it less than 0? So where is 6x squared minus 12 less than 0? That's 6x squared less than 12, x squared less than 2, and absolute value of x less than the square root of 2. Well, when it is less than, it splits into a compound sentence. So negative square root of 2 is less than x is less than the square root of 2. Or these numbers right in here. So where is this function decreasing? It's decreasing from negative square root of 2 to square root of 2. Okay. I'm going to go ahead and stop it and make this part a